Hi everyone, this is the 24th lecture of IE 451 Engineering Economy. So let's solve problem 6-46. Two mutually exclusive alternatives are being considered. One of the alternatives must be selected. Using 15% nominal interest rate compounded continuously, determine which one, and solve by annual cash flow analysis. So, as usual, let's draw the cash flow diagram based on this cash flow table. So we are working on problem number 6-46. So for the alternative A, the initial cost of $3,000 are required, and then over the next 5 periods, there is an annual benefit of $845. Okay. And for the alternative B, first cost of $5,000 are required, and then over the next 5 periods, there is an annual benefit of $1,400. Okay? And the interest rate we are going to use is 15% nominal interest rate compounded continuously. Okay? And earlier we've learned with neither input nor output fixed, we have to maximize EUAW, that is equivalent uniform annual worth, okay, which is this case, problem 6-46. And how would you get EUAW? Equivalent uniform annual worth can be computed by equivalent uniform annual benefit minus equivalent uniform annual cost. Okay? So we are going to use this formula for problem number 6-46. So for the alternative A, equivalent uniform annual worth for alternative A be computed by equivalent uniform annual benefit minus equivalent uniform annual cost. And according to this cash flow diagram, equivalent uniform annual benefit would be $845 minus equivalent uniform annual cost should be related to this number, initial cost, $3,000. But this initial cost of $3,000 should be converted to an equivalent uniform annual cost. So 3,000 times A given P, 15% over 5 periods. However, here we have to use continuous compounding, capital recovery factor. So if you look at our text, page number 129, the bottom of page number 129, it does provide the formula for continuous compounding capital recovery factor, which is 4-32, equation 4-32. So we are going to use this formula. Okay. So here, A given P, 15% over 5 periods would be same as e to the power R. R is 15%, so 0.15 times N. N is 5 times e to power R, which is 0.15 minus 1 over e to power Rn, so 0.15 times 5 minus 1. Okay? So how much is this? Okay, so this number should be 0.30672. So what is the equivalent uniform annual worth for alternative A? That's going to be 845 minus 3,000 times 0.30672. So we have negative number here, negative $75.16. That is the equivalent uniform annual worth for alternative A. Okay, then what about the equivalent uniform annual worth for alternative B? So equivalent uniform annual benefit for alternative B would be $1,400 minus you need to convert initial cost of $5,000 to the equivalent uniform annual cost. So minus 5,000 times A given P, 15% over 5 periods. So how much is that? So from the case A, we know that this factor value is equal to 0.30672. So this number should be 1,400 minus 5,000 times 0.30672. Okay? So how much is this? We have another negative number here, which is negative $133.60. So it looks like we should avoid both of these plans, A and B, because both of them provide an equivalent uniform annual worth of negative values. Right? However, according to the problem description, one of the alternatives must be selected. There is no other choice, right, available. So, what is your conclusion? This is, okay, from plan A, the equivalent uniform annual worth of negative $75. From plan B, equivalent uniform annual worth of $133, negative value of them. So in order to maximize equivalent uniform annual worth, you need to choose alternative A because it provides less negative value. Okay? Okay, so there is problem 6-46. Okay, then next problem that we are going to solve is 6-49. A certain industrial firm desires an economic analysis to determine which of two different machines should be purchased. Each machine is capable of performing the same task in a given amount of time. Assume the minimum attractive return is 8%. And then which machine would you choose? Base your answer on annual cost analysis. Okay? Okay, so we are required to answer this question based on annual cost, right? So We are working on problem number 6-49. So let's draw the cash flow diagram for each machines. Okay. So for machine X, there is a first cost of $5,000 required. And there is no annual maintenance cost, and there is no service values after its useful life of 5 years. Oops, 0, 1, 2, 3, 4, and 5. So that's it. Okay. Very simple cash flow diagram. So in this case, equivalent uniform annual cost would be, you need to convert $5,000 to the equivalent uniform annual cost. So 5,000 times A given P, and we are going to use 8% of interest rate over 5 periods. So how much is this? 8% A given P over 5 period is 0.2505. 0.2505. So how much is that? Okay, so this is $1,252. $1,252. That is the equivalent uniform annual cost for machine X. For machine Y, the first cost of $8,000 are required, and then for the next 12 years, annual maintenance cost of $150 are required. And then at the end of, is 12, right, instead of 15. At the end of is estimated life of 12 years. There is a service values of $2,000. Okay. So how do you compute equivalent uniform annual cost in this case? And in our text, page number 193, if the initial disbursement P and the service value S is given, then the annual cost can be calculated by these three equations, 6-1, 6-3, and 6-4 in our text page number 193. So we have to use one of these formula to compute the equivalent uniform annual cost for machine Y. So first, this cash flow diagram can be broken into two components. One for the uniform annual cost of $150. And then another one for initial cost of $8,000 and salvage value at the end of its useful life, which is $2,000. Okay. So you are going to use either of these three formulas, 6-1 in page number 193. Equivalent uniform annual cost is P times, there is the initial disbursement, A given P, I over n periods minus service value, A given F, I over n. Okay? Or formula 6-3, 6-3, equivalent uniform annual cost be P minus S, A given F, I over n plus P times I. Or the third formula, 6-4, equivalent uniform annual cost can be computed by P minus S times A given P, I over n periods plus service value I times service value S times I, the interest rate I. Okay? So you can go either of these three formulas. Okay? And I will just arbitrarily select the third equation. So we are going to use the third formula. So in this case, we are going to use EUAC is P minus S, A given P, I over n periods plus S times I. Okay? So how do you get the equivalent uniform annual cost for the machine Y? That's going to be 150 from this first cash flow diagram plus. Now we are going to use this formula for the second cash flow diagram, right? So P, which is 8,000, minus S, that is 2,000, times A given P. I is 8% over 12 period, plus S is 2,000 times I. I is 8%, so 0.08. Okay? Sorry, let me write down this part again. 2000 times 0.08. Okay? So if you compute this, then it will provide you equivalent uniform annual cost for machine Y, which is same as this or this. Okay? So A given P, 8% over 12 period. That is 0.1614. So right, A given P, 8% over 12 periods, 0.1614. So how much is this? I'm sorry, but I was looking at other values. We are looking for 12% of interest rate. No, we are looking for 8%. I was looking for 12%. So the 8% of interest rate and A given P over 12 period is 0.1327. Sorry. It's going to be 0.1327. So how much is this? Okay, so it's going to be $1,106. So here from machine X, the equivalent uniform annual cost is $1,252. From machine Y, equivalent uniform annual cost is $1,106. So you need to choose machine Y, right? Because it will cost you less amount of money. So this is the problem 6-49. Okay, next problem that we are going to solve is, how about problem 6-51. Consider the following two mutually exclusive alternatives. Alternative B may be replaced with an identical item every 20 years at the same $150 of cost, and will have the same $24 of uniform annual benefit using a 10% of interest rate and an annual cash flow analysis. Determine which alternative should be selected. Okay, so we are working on problem number 6-51. Because we assume an identical replacement, we may compare 20 years of plan B with an infinite life for plan A by using equivalent uniform annual worth, okay, which can be computed by equivalent uniform annual benefit minus equivalent uniform annual cost. Okay? So we are going to use this formula for solving problem 6-51. So for alternative A, equivalent uniform annual worth would be equivalent uniform annual benefit minus equivalent uniform annual cost. But you gotta be careful when you compute the equivalent uniform annual cost. You have to consider for an infinite number of periods. Okay, so for an infinite number of periods. Okay. So here, equivalent uniform annual benefit would be $16. And then equivalent uniform annual cost would be 100 times A given P, 10% of interest rate for how many periods? For infinite number of periods. Okay. So what is this value? That's going to be equal to 0.10. How do you know this? It's 0.10, which is just 10%. If you look at our text, page number 200, right here, it describes how to deal with equivalent uniform annual cost for an infinite analysis period. Okay? So here it says at times we have an alternative with a limited useful life in an infinite analysis period situation. The equivalent uniform annual cost may be computed for the limited life. The assumption of identical replacements have identical cost, performance, etc. is often appropriate. Based on this assumption, the same equivalent uniform annual cost occurs for each replacement of the limited life alternative. The equivalent uniform annual cost for the infinite analysis period is therefore equal to the equivalent uniform annual cost computed for the limited life. With identical replacement, equivalent uniform annual cost for infinite analysis period is equal to the equivalent uniform annual cost for limited life of n periods. And when n goes to plus infinite, here, and goes to plus infinite, we have A equals P times I. So A given P, I over plus infinite equals I. Okay? So it says so right here. Okay? That's why up here, A given P 10% over plus infinite analysis period becomes 0.10, which is the value of I up here. Okay? So this value, equivalent uniform annual cost for alternative A, would be 16 minus 100 times 0.1. So 16 minus 10 would be just $6. Okay? And for alternative B, equivalent uniform annual worth, B equivalent uniform annual benefit minus equivalent uniform annual cost, right? In that case, equivalent annual uniform annual cost for 20-year period. Okay? So how much is that? For Plan B, uniform annual benefits of $24 are required. $24, and then equivalent uniform annual cost of $150. So 150 times A given P, 10% over 20 periods. So what is the table value for this? 10% A given P over 20 periods. That is 0.1175. 0.1175. So how much is this? Okay, that is $6.38. So if you compare these two numbers, for alternative A, equivalent uniform annual worth is $6. For alternative B, is $6.38. So definitely you need to choose alternative B. Okay? Because the equivalent uniform annual worth $6.38 is larger than just $6 for plan A. So you got to go with plan B, alternative B. Okay, so this is the problem 6-51. And next problem that we are going to solve is problem 6-54. Okay. The manager in a canned food processing plant is trying to decide between two labeling machines. So in this table, there are two labeling machines. Machine A and B are recorded. And for each machine, the first cost, maintenance and operating cost, annual benefits, service values, and their useful lives in years are recorded like this. And assume an interest rate of 12% and use annual cash flow analysis to determine which machine should be chosen. So we are working on problem number 6-54. So again, we are going to use the criterion, which is to maximize the equivalent uniform annual worth, which can be computed by equivalent, this is EU, equivalent uniform annual worth can be computed by equivalent uniform annual benefit minus equivalent uniform annual cost. Okay? So for machine A, equivalent uniform annual worth would be first cost. First of all, you need to consider the first cost. That's going to be negative $15,000. And you need to convert it to equivalent uniform annual cost. So A given P and 12% of interest rate over 7 years, right? And then annual maintenance and operating cost, which is $1,600. And also you need to consider annual benefit, which would be plus $8,000. And then you need to consider service value at the end of its useful life of 7 years. So plus $3,000, but this number 3,000 should be converted to equivalent uniform annual benefit. So you need to multiply by A given F 12% over 7 years. Okay? So let's get these table values. 12% A given P over 7 periods, that is 0.2191. 0.2191. A given F, 12% over 7 periods, 0.0991. 0.0991. 991. Okay. Then how much is this? That is $3,411. That is the equivalent uniform annual worth if you choose machine A. Okay. Then how about for machine B? Equivalent uniform annual worth. Excuse me. Okay, so let's consider the first cost, which is negative 25,000. You need to convert it to equivalent uniform annual cost. So you need to multiply by A given P, 12% over its useful life of 10 years, minus annual maintenance and operating cost of $400, and plus annual benefit of $13,000. And also consider the salvage values at the end of its useful life, which is 10 years. So 6,000 times A given F, 12% over 10 period. Because you need to convert the salvage value to equivalent is equivalent uniform annual benefit. So you need to multiply by this factor. And we are looking at 12% A given P over 10 periods is 0.1770. And A given F, that is 0.0570. 0.0570. Okay. So how much is that? This value should be $8,517. So what is your suggestion? We've got $3,411. That is the equivalent uniform annual worth if you choose machine A, and $8,517 if you choose machine B. Obviously, you should choose machine B to maximize the equivalent uniform annual worth. Okay? Okay, so that is problem 6-54. And Well, I think this is all for today. So next time we are going to talk about chapter 7. So I want everybody to read our chapter 7 before you watch the next lecture. Okay, thank you very much. I'll see you next time.